Very good afternoon to one and all. It's a pleasure to introduce Dr. Sagar Nikam, who is going to deliver his presentation on process monitoring and defect detection using AI in vehicle components. Dr. Sagar Nikam holds a bachelor's degree in production engineering from Shivaji University, Maharashtra, India, and a master's degree in manufacturing technology from NIT Trichy, India. He completed his PhD at the IIT Indore. Following his doctoral studies, Dr. Nikam served as an assistant professor in the Department of Production Engineering at the Birla Institute of Technology, Mesra, India. He is currently a lecturer in mechanical engineering at Ulster University, UK. Prior to his current role, he worked as a postdoctoral research associate at Ulster University, contributing to the Northwest Center for Advanced Manufacturing project through his work on simulation modeling for the selective laser melting process. Dr. Nikam's research expertise includes the development of AI-driven process monitoring systems for additive manufacturing, with a focus on advancing the efficiency and reliability of cutting-edge manufacturing technologies. So you're welcome to deliver a presentation, sir. It's an honor to have you.
Yeah, great. Good afternoon, all of you, and thank you very much for to Dr. Abdur for this brief introduction, and thank you very much to Dr. Jay Kumar for inviting me to deliver this talk on FDP in AI in electric and hydrogen-powered vehicles. So in this talk, I will be talking more about process monitoring and defect detection using AI in vehicle components. As of now, Dr. Abdur gave his brief introduction about myself. I basically work on using some AI in process monitoring for additive manufacturing process. But I have aligned some of my talk with some vehicle components, like how process monitoring of the vehicle components are done, or how the damages in the vehicle components are being detected. So this is more on how we go for predictive maintenance of the vehicle component. So my talk is divided into three main topics. So first we'll look at what are different type of damages or defects that are taking place in vehicle components. Then what are the different monitoring systems in vehicle components? So obviously nowadays vehicles are becoming too much smart as well, and we use a lot of sensors, all those things which can be monitored offline and online. So those we're going to just take a look at those aspects of how the monitoring system in the vehicle works, and then how's the AI useful for detection? For example, if monitoring system captures the data, and how is being AI is used to gather the information out of it and give us some informed decision of any defects or any conditions of the vehicle components. So just introduction of this particular thing. So in this introduction, I would like to talk about how to manage and protect important vehicle components, so that are not only expensive but are also crucial for vehicles' performance. So these expensive components are gear transmissions. This can sometimes develop damage or defects due to regular wear and tear. So even heavy usage or even manufacturing issues. And if these are not detected early, so this can causes issues. And if they're not detected early, so this can lead to the bigger problem, causing the vehicle downtime and also even costly repair. So to solve this, nowadays we make use of advanced AI technology. So AI-based object detection system. So where the AI helps us to pinpoint the defects or damages in the components, and it helps you to excuse the signs of any damage or defects in the part. For example, it can spot the crack, it can spot the dent or unusual wear patterns in the surface of these components. So what's impressive is that it doesn't just detect issues, but it also categorizes them. Okay, so it helps you to understand what type of defect it is and how severe is the problem. And this particular information is being very helpful for mechanics or engineers to take some informed decision and fix this particular issue in the good time. So what makes the solution even more powerful is its ability to work in real time. So that is where actually the new things are coming real time, gathering the data or in real time. So this system like constantly monitors the vehicle components while they are actually in use. So instead of waiting for the routine checkup or for the part to fail, it alerts us with the breakdown and ensures that the vehicle stays operational longer. So the takeaway message from this is like AI is really powering the monitoring system because it helps you to capture the data in real time. It helps you to understand the damages in real time, and it is not like fixing the problem after it's damaged, but it's like preventing the problem beforehand. So it's like a proactive system. So now let's look at what are the different types of defects or damage that can take place in the vehicle components. So even like vehicle components are like mechanical components that are being used. So those are oftenly are subjected to stress, friction, and the environmental factors, which can lead to the various type of issues. So identifying and understanding this type of damages is crucial for maintaining the performance and safety of vehicle. Like if you look at the first damage here, like dents or digging, which often happens when a component is hit or impacted by another object. But this looks like a minor, but if not rectified earlier, then it can cause a lot of problem. Next is the plastic deformation, where the material is being permanently bent or reshaped under stress. So this can reduce the part effectiveness and lead to further mechanical failures. Another is like air deterioration, which happens when the edges of the component wear away over time, often due to the friction of stress. And then another is like a wear, which refers to the gradual removal of material from the surface of the part, which is one of the most crucial issues in the high usage component. Another critical damage is like crack, which can develop due to the repeated stress in a sudden impact. The cracks are particularly dangerous because they can go to the lead to catastrophic failure. So like finally, there is the defect is like a heat check. So this is like the defects that are occurring on the high temperature surfaces or with surfaces that are being exposed to high temperature. So what happens due to this high temperature is repeated like heating and cooling. So that develops some sort of like small cracks on the surface. So this like usually occurs, this type of defects are usually occur in the brakes or engines where the high temperature is being involved. By categorizing or identifying this defects, usually like we can take a step of repairing or replacing the particular affected components early, and that can ensure the smooth running of the vehicle. If we take a look at different type of damages, so understanding the categories of damage is very important from AI part. So AI is obviously it's a data-driven thing. Obviously, we human need to train that particular AI model based on data. But as we are involved here, humans are involved, where humans should know like what type of damages it is, what are the categories of damage in that category, what type of damage. So this damages. Understanding of these damages like are very important because it helps you to take some informed decision. Obviously, like AI can help you give some optimized solution, optimize understanding of the damage, and help you with the good repair understanding. But we need to train as a human, we need to train AI model. So first of all, we need to understand like what are different damages in the mechanical components, and how to use this particular categories to train the machine learning model. So usually like damages are categorized in three main categories. One is the catastrophic damage, the manufacturing damage, and operational damage. So like manufacturing could be like in the manufacturing process, all that like, but in the vehicle components, like catastrophic damages and operational damage are very common. So first, let's take a look at the catastrophic damage. So these are often caused by major issues like faulty design or some extreme loading condition, or by using some defective material. So or by like improper handling of the particular material, or improper storage of that particular material during transportation. So this type of damages are very severe damages, and it affects the quality of the material. So it's proper analyzing of this catastrophic damage or understanding the pattern of the catastrophic damage is very important to maintain the vehicle component, health of the maintenance component. Next, in the manufacturing damage, which occurs during the production process, for example, like using wrong manufacturing process or fail to follow specification, that can result in component that do not meet the design standard, or again, like improper storage can also compromise the integrity of the part, or poor inspection and quality control can also allow the defects to go unnoticed. So this is like another manufacturing damage. And then the last finally is the operational damage, which happens when the components are in use, when this can be due to the improper work environment, such as like excessive heat, moisture, or vibrations, or mishandling of or improper use of component by operators. That also like is one of the common causes here in the operational damage. Like for example, if incorrect parameters are set during operations, or the components are reconditioned improperly, so this can lead to the premature failure. So by breaking these damages down into these categories, we can better understand why the problems occur. This framework actually helps in targeting specific areas like design, manufacturing, operation, and for improvement, ensuring that the components are more reliable, efficient, and long-lasting. So here we will take an example of one of the catastrophic damage in the vehicle component. So you know that the gear is like very high value component that is being used in the vehicle. Yeah, so in this particular figure, it shows there are different catastrophic damages that are taking place on the gear, which is like a critical component in almost every vehicle. So usually gear is being used for transmission, and any failures here can lead to the major operational issues. So there are two main common types of catastrophic damages in this vehicle component. These are like cracks and the broken teeth. So if you look at the crack here, so this occurs when the material is exposed to repeated stress, such as high load or thermal cycles, which eventually cause a small fracture to form. And over the time, this cracks grows larger, weakening the structure of the gear and increasing the risk of failure. So like for instance, a crack on a gear tooth can compromise the gear ability to transfer torque effectively. The other type of damage is like a broken teeth, so which is even more severe. That happens when the stress on the gear exceeds the material capacity, often due to sudden shock loads or poor maintenance or defects in the material itself. A single broken tooth can cause a misalignment and impact to the entire drivetrain, potentially leading to the further damage in the connected components. What particularly important is to note is how such damages are not just a result of normal wear and tear, but can also stem from factors like improper use, lack of lubrication, or manufacturing defects. And AI can help us in early detection of these issues and can prevent us from the catastrophic failure. Another type of defect is like another example is like in the operational damage. So manufacturing damage, like it's more on the manufacturing side, but catastrophic and operational damage, they are like when the particular components are installed on a vehicle and being that big use in certain environment, and how that usage is being affecting or damaging the product. So the catastrophic damage, and another one is the operational damage. So like operational damage occurs when the components are exposed to challenging conditions or used improperly, which can significantly affect their performance and lifespan. Like first we take a look at the impact of the adverse driving condition. So this includes like situation like rough terrain, uneven surface, or driving an extreme environment such as excessive heat, dust, or moisture. These conditions are put additional stresses on the vehicle component, especially gears, like as shown in the figure here on the right hand side. Over time, such stress can lead to the surface damage like pitting or material fatigue. So another major cause of operational damage is like avoiding proper and timely maintenance. Like for example, skipping regular checks for lubrication, alignment, or wear can lead to the faster degradation of component. So when gears or other part operates without sufficient lubrication or friction, that increases and causes the surface to heat up, and this heating up wears the surface of the like gear component prematurely, causing the damage to the surface or heavy wear and deterioration. The third factor that affects operation is like using the components under high temperature or high loading conditions. So this happens when the vehicles are pushed beyond their design limit, such as carrying excessive loads or running for extended period without cooling breaks. So like running for more time. So high temperature can weaken this material, while causes excessive loads can increase the stress on the component like gears, and that can lead to the premature deformation of surface. Here, the image on the slide shows a clear example of such damage, like the surface of the gear is being damaged if the particular piece of components is not used or under good operational conditions, or like if there is like if the particular components is being used like in adverse environment that causes the defects. You can clearly see there's a pitting of the gear surface on the tip there. So this was all about the damages. So this was like as we talk about like that catastrophic damage and the operational damage, the two main categories that comes under the vehicle component. Next time comes about monitoring. Now, how to look at these defects, how to capture those defects. So this is another crucial part, okay, because vehicle system itself is a very complicated thing, and getting a useful data out of it is very important, because AI completely rely on the data. Unless and until you have a good data, AI can't give us a good informed decision. So next important thing here is monitoring the damage and defects in the vehicle components. So nowadays, like in the modern system, where we use the vehicle. So for every thing, there is a sensor placed in the vehicle. Like you want to monitor the tire pressure, there is a sensor. So everything nowadays is monitored by the sensor in the equipment. And also along with the sensor. Any questions here? Right. So continuously monitoring the health of the key is very important thing. And for this purpose, like we have our one sensor and onboard diagnostic systems there. So the sensors usually track the parameters like temperature, pressure, vibration, and also the load in real time. And that helps us detecting the early sign of damage and defects. So that is like the term for predictive maintenance. So by doing this, like they provide us a valuable data that can prevent the failures and reduce the downtime. So the figure here on the right hand side that illustrates the critical vehicle component, such as like engine, turbocharger, transmission system, cooling system, and brakes. Each of these systems play a vital role in the vehicle overall operation, and even a major issue is one can lead to the significant problem if they're not addressed earlier. Like for example, excessive heat in the engine or transmission can cause wear and tear, or like abnormal vibrations in the turbocharger or brakes may indicate cracks or imbalance. So this monitoring of this is very important, because in this particular thing, to monitor this, like sensors are being used, and sensors are installed in a critical location to measure the performance, and that particular components can send the useful information. Like for example, temperature sensor in the engine can detect overheating, or the pressure sensor in the cooling system can identify the leaks and the blockages. So this is how the main takeaway message from this slide is like the vehicle components. There are different has different vehicle components like brakes, transmission, engines, and all the things. But the sensor is one that monitors its health and helps you to capture the data. So now we are going to look at real-time monitoring. So obviously, like nowadays, sensor do that real-time monitoring. But if we have a monitoring system in every car, like if you, for example, if you look at the car there, and let's say, for example, there is a tire pressure monitoring sensor. So what happens? The sensor tells you on the dashboard when the tire pressure goes down. At that time itself, it tells you, okay, now the tire pressure is down. Now you need to fill the air. So that is like it's not a proactive sensor information. So we don't do it at real time. We don't get data in real time. Obviously, sensor is capturing the data in real time, but we don't get that information in real time. But real time monitoring is very important nowadays. Like that is like mostly done in EVs. Those EVs are coming into market. So real-time monitoring of vehicle components is very important. So for this purpose, like for real-time monitoring, we make use of like vision-based system, or also like there are test benches designed in the labs which are being used for data collection. Like like for example, you can see the test bench here at the bottom left figure. The test bench is of engine, which captures each and every data for our engine. So that is like you capture the data, you test the model based on the data you receive, and then once the model is tested on this test bench, you can just deploy that validated model on your actual engine there, and then that particular can help you to track the health of the vehicle components in real time. Also, like vision-based systems are being utilized. Like there are cameras or advanced image processing techniques that monitors the vehicle in real time. Like for example, here a figure on the right side which shows the road, and which can help you to track the vehicle. It can help you to track the speed, direction, and the type of vehicle, whether it's a car, bus, or truck. So, and also this system can help you monitor traffic flow, detect abnormalities, and help identify potential issues, such as overloaded or improperly maintained vehicle. Like there was one study recently I saw, like they used a vision-based cameras on the road to monitor the health of the vehicle. So based on the vehicle driving conditions, it will track the speed. Like for example, if particular vehicle is driving at high speed, and that could potentially lead to some accidents. So what happened? Those cameras the cameras are installed at particular distance on the road, and this particular camera will give instruction to the traffic monitoring system of the city, and then it will tell that this particular vehicle is running at too fast and the driver is not slowing down this vehicle, and this could be like potentially causing what do you say, the accident of the vehicle causing the damage. So then the traffic monitoring system alerts their own system, and they try to catch this particular vehicle, make sure that this particular vehicle doesn't cause a damage or accident on the road, causing the traffic on the road. So that was one of the study recently I read. So it was not in the paper, it was a magazine where I think that what particular system was influenced here in like Birmingham here in UK. So that was how they're making use of this real-time monitoring system, real-time monitoring sensors to capture the health of the vehicle or any kind of conditions of the vehicle there. So now this is some of the examples that I took from the previous test bench. So like, for example, in the previous test bench, a lot of things were captured. So one of the data was like real-time torque monitoring. So they monitor the engine torque from the test bench, and they just want to check how this engine perform, and they analyze this data and validate it using the control condition. So in this figure on the slide, on the left-hand side figure, we can see the schematic of the engine system. So the blue arrow represents the flow of air as it moves through the system, starting from the intake air filter, passing through the compressor and intercooler, and finally entering the engine block via the intake manifold. The red arrow represents the flow of heat gas produced during combustion. So this gas revs the turbine shaft, and which power the compressor to the turbocharged system. So this flow diagram gives a clear picture of how the air and exhaust gas moves through the system. Now on the right side, we have a graph which shows real-time torque monitoring. I'm not sure whether you can see the blue line. So there is a blue line where the sensor records the actual torque, and then based on the data from the torque, the model is being trained, and a time series model is being divided, or we can say a real-time model is being designed, which helps you to track the actual torque of the engine. So there is another red line which shows the reference torque. Reference torque is like it shows that your engine is your blue line, which is actual torque, and your reference torque should go together. If there is any abnormality between the system or any kind of a issue between the with the engine torque, then suddenly there is a spike in the in the lines there, and which gives you the idea that okay, now this particular engine is not performing to the mark that you expected. So that is at a point like we can carry out the engine maintenance work or something like that. So that is like more aligned with the predictive maintenance thing. Another thing, important thing is condition monitoring. So it's very critical part or critical process for ensuring the reliability and efficiency and the longevity of the various mechanical component. So condition monitoring, condition itself, like word itself says that condition means the how is a behavior of the particular vehicle component when they are deployed to the actual environment, in an actual environment or actual conditions. So monitoring all those conditions. So like there are different mechanical components in the vehicle, like rotaries, machines, compressor, pumps, other motors in the vehicle component that makes that which condition needs to be monitored. Okay, so traditionally the condition monitoring often relied heavily on the vibration. So like previously what was done, only vibrations were measured using sensors, and based on that the analysis was done whether and if there is any irregularities in the in the component, or if there is any misalignment, imbalance, or wear in the component. Okay, no, vibration analysis is not absolute. It's still being very important tool nowadays. It's still being used for capturing the sensors, but there are other ways as well along with the vibration which can help you to give the actual picture. Okay, so like for example, there is like a tomography sensors, like we can call it as like infrared sensors, or also the thermal cameras or normal cameras that can help monitor the temperature change in the components. Like for example, if we can use the thermal cameras to monitor the overheating in a gearbox or engine, that can indicate the lubrication. So this camera usually not just give the value, but it also gives you the picture about like what actually is happening within the system. Or like tribological sensor, which usually analyze the lubrication and the properties, like for example viscosity or any presence of contaminant in the lubrication that can cause the damage to the vehicle components. Then the photo visual inspection. Photo visual, like once you have any picture of any component, like picture of crack, corrosion, deformation, or any damages in the vehicle component. So based on that, you can analyze the type of defect, type of damage, and accordingly the measures can be taken. So the model techniques, like they go beyond this intuitive method by incorporating sensor technology to measure multiple parameters in real time. So sensors can track like temperature, pressure, vibration, and even more, providing immediate alerts when component condition deviates from normal threshold. So the takeaway message from this is like the condition monitoring is evolving from the traditional methods to more advanced and data-driven approaches. And by combining different techniques and leveraging the sensor data, we can achieve real-time insight optimizing of the vehicle conditions and ensuring the smooth operation of the vehicle. Sorry. Then actually how this condition monitoring thing works. So there are actually three main steps taken up when we do condition monitoring of any components. So one is like installing the monitoring system, installing the sensors or hardware on the actual, because it is not like we can't fix sensor anywhere. It's very important to identify the location at where the sensors can be fixed in. Then we need to capture such at least that amount of data which will give you the basics or baseline, okay, or the reference point. Okay, so that reference point is like considered to be like a threshold. So any future values captured by the sensor crosses that baseline or threshold, then like it's like we consider that particular stage as like it need to be maintained. Okay, so in the first step, like installing the monitoring system, we need to install the necessary monitoring hardware on the equipment. So this could include the sensors or measuring parameters like vibration, pressure, temperature. Okay, so depending on the type of vehicle or the machineries, we need to select the thing. So like for example, the sensor on the engine might be very different from the sensor that on the braking system. Okay, so and the next step is the baseline data measurements. So once the system is being installed, the next step is to collect the baseline data. So this involves measuring the normal operating performance of the equipment under standard conditions. So data such as like vibration pattern, rotating speed, temperature ranges, and other sensor readings are recorded. So baseline usually becomes a benchmark or a threshold, allowing the system to identify when the performance deviates from this normal. Like for instance, like if the vibration in a gearbox exceeds the baseline threshold, it can indicate like there's a developing issue of misalignment or bearing wear, etc. And then ongoing monitoring. So once we have a baseline thing established, the next thing is continuous monitoring of that and checking that data against the baseline data, as I said before, just to make sure that our any our future data won't crosses that baseline or reference point or threshold point. And if it crosses, so that's the point of like we need to check the defects or damages, and it requires some predictive maintenance of the vehicle. So usually this condition monitoring process usually that ensures the proactiveness. So we actually allowing us to address like potential problems before actually they escalate, and by combining the baseline measurement data with real-time data and any using some advanced diagnostic tools that can help us to optimize the vehicle condition. So this is one of the example for the condition monitoring of the gears. So in this image on the right shows how sensors can use how sensors are being used to capture the vibration in the gear or the health of the gear. So for that purpose, like accelerometer sensors are being used, and this sensor being integrated with the system. So accelerometer sensor play a key role in measuring the vibrations when the gearbox or drive systems are in operation. So vibration that exceeds the normal operating level can indicate a problem such as gear misalignment, wear, or the bearing failure. Then the bottom image, which provides a real world example of a gear box casing and level gear accuracies as gear assemblies with the component like helical gear or spur gear. So this image illustrates the physical setup of the component within the drivetrain. So operating under adverse conditions like high temperature or high loading can cause wear and tear on this part. So like for example, high temperature can weaken the material, and this can cause excess load on the gear, leading to the damage. So condition monitoring ensures that such issues are being identified early, and by analyzing real-time data from sensors, the system can track performance and compare them to baseline values and generate alert with abnormalities of that are detected quite earlier, and help you to condition or overhaul the vehicle quite early. So the takeaway message from this particular is that it's very important to monitor the condition of the vehicle components, especially the critical vehicle component that can stop, or like it can damage the component, and it can lead to the downtime of the vehicle, or it can also reduce the lifespan of the components. So condition monitoring is like identifying the defects or damages beforehand and making the thing. So this is the result or outcome of the the accelerometer sensor that was seen previously, which captured the vibration signals, and based on the vibration signals, no decisions are being made. Like for example, here like either is increased amplitude in the vibration signal, so this the signal might suggest that there is a misalignment in the gear or an imbalance in the drive shaft, or if there is an improper, it's like usually we look for a good proper pattern or a trend line, but suddenly there is a change in the trend line where from which the data is coming in. So we can say that the point there is a high wear and tear at some point, or there is a pitting on the gear teeth or crack that can causes high stress, or like suddenly, like for example, data has been captured smoothly, but suddenly there is a high spike. So now this is like high severe problem. So it indicates like there is a damage in the in some of the component. Like for example, if we take the gear component, then there can be damage in in the gear tooth. It could be like a broken tooth, so that is causing a lot of sudden vibrations in the component. So this is how the informations are being made based on the data that is being captured from the accelerometer sensor. Another is like the condition monitoring of the suspension. So this is another very important vehicle component which play a critical role in ensuring the vehicle stability and comfort and safety. Okay, so here's the figure on the right hand side provide the dynamic representation of the suspension system. So it shows the interaction between the different components, including the car, body, ace, arm spring, and vibration, and the exciting vibrations. So these are the three different components that help us to capture the data or vibration in the spring. And another is the condition monitoring of the braking system. So here the sensor is like the temperature sensor is being used to continuously monitor the brake pads or the disc of brake disc. So that helps you to capture the condition of the the brake element there. So here is like the based on, like for example, if there is a sudden rise in temperature, so it is like there is a high friction between the pads and the disc, which can say that there's a lubrication problem, and we need to overhaul the vehicle for good lubrication. Or like for example, if there is a sudden if the temperature increases a certain limit, which causes like very high heating of the disk, so that can also be captured using the sensor there, thermal sensors, or we can say the IR cameras, or we can also use some sort of like thermal imaging cameras, which helps you to monitor the condition of the braking system. And if the temperature exceeds a certain value, so we can say there is a wear and tear in the brake or the pads in the brake, so that needs to be replaced or changed. So this is about the condition monitoring. So these are the different type of sensors additionally which are being used to monitor the conditions. So there are more, but there are like sensors like pedal sensor, pedal force sensor. So this is like sensors are being used to monitor the pedal, like you're pressing the accelerator, brake. So how everyone has his own driving conditions, and this is like how the particular pedal force. So some might apply like small less amount of force, some might apply higher amount of force. So in that case, like this type of sensors are being used. So there is a wheel speed sensor that can monitor the speed. There is a sensor on steering torque, so the speed of rotating, how the steering being operated. Then there is a tire pressure sensor, which is very commonly used in the every vehicle, and the brake temperature sensor, which is generally monitor the brake conditions. So previously is like usually that particular conditions we call as an offline conditions. Like there is a sensor placed on the vehicle component, and we collect the data, and then we use that particular data to capture or make some informed decision. But now as we are advancing the technologies, like even like there are even electric vehicles are coming, especially like with where the Tesla is there. Even in India, like there are different EVs are coming, which make use of online condition monitoring. Also, there are like all other heavy equipments where they go for online condition monitoring. Online condition monitoring is like more on like Internet of Vehicles, that is called actually IOV, Internet of Vehicles, where they monitor the condition of vehicle at some other part of the location. And this particular sensor that continuously share the data with the dashboard that is somewhere at the another location. So it's like monitoring the condition of the vehicle from certain distance and making the informed decision in real time, and continuously looking at the machine or any vehicle components, and giving the instructions, like if there is any interruption or there's any problem with the machine, then giving the indication to the operator of the machine or the vehicle beforehand, and telling them of any kind of issues with the vehicle component. Now, how AI or ML is helping in monitoring. So now till now, we looked about how the data has been captured. So whether it's through sensors, even it's a sensor like monitoring is like offline monitoring, or we are doing it through online monitoring. Now, let's try to understand how AI and machine learning is helping the monitoring system. So like particularly in the context of like vehicle condition monitoring. So AI is like, it's not a new thing now. It's like used from traditional computing system. So initially, like when we used AI, it lack of intelligence. So it was just help you understand the trend line, but it didn't give any kind of optimized instruction or information to you. So initially, like when we use artificial intelligence, so that was like to mimic the human intelligence, and it allows the computer system to make a decision and adapt to new information and solve the problem. It's like how human operate in uncertain conditions. Like for example, AI can analyze the sensor data to detect pattern and abnormalities, and that was like previously missed when we use a traditional thing. AI is like very broad term. Under AI, there are different subsets where the condition monitoring is being done. So like, for example, under AI, machine learning comes. Obviously, this is one of the most powerful technology which is being used in condition monitoring. Then the ANN, artificial neural network, to help them get the informed decision. The deep learning model. So obviously, the data is getting larger, more heavier. So there are different deep learning techniques which makes this kind of a this kind of analysis quite lighter. And also there are different type of data, not only vibration data, but like they have different type of data coming in, like image, videos. Okay, so these are like deep learning approaches usually help in understanding those things. Then comes as the computer vision. So this is another very important or powerful tool in monitoring, where AI is being used for computer vision. So like previously in one of the slides I showed about the vehicle tracking system, where the cameras are being used to track the vehicle. So the computer vision is that part where we use like object detection models. So there are a lot of object detection models, like one is like YOLO, even CNNs, those are like categorized as object detection model. So that usually that things are being used to analyze the images or videos, and this computer vision is really helpful in detecting cracks, corrosion, or misalignment. Because even like nowadays we get a camera, small chip like a chip like thing, which is just easy to install on any mechanical component, and that usually helps you to understand, not only just look at the health of the vehicle, but also it will help you to give the informed decision of the vehicle, like how is the condition of it, whether it is good or bad. So that is the role of computer vision there. Then NLP, natural language processing and speech recognition. Now this again, the new thing is has come up, NLP, or we call it a LLM, large learning models. So this ChatGPT thing, which is categorized like which comes under the LLM model. So now to get more informed decision, optimized decision. So natural language processing is being used, where they make make use of sensor data, and based on the sensor data, it will give you an optimized solution. So that will be helpful for monitoring the condition of the vehicle there. So if you look at the first category of the AI, that is the machine learning. So again, it's a subset of the what do you say the AI. Machine learning it provides a system with the capability to learn from data without being explicitly programmed. Okay, so it takes information from the data, and it helps you to understand the system. So like if we just break down the concept of machine learning, so the primary goal of machine learning is to impart the learning to machines by feeding the system with large amount of data. It's expected that it should be real world data, but capturing data is also not that easy. So nowadays, like even researchers are coming with the simulated data. So what they do, they validate a simulation with the real world data, and they get that use that simulation data to train the machine learning model. So like it's just like not feeding straight for way, but just feeding over the head. But at the end, the most important thing is that your model should give you the desired output that you are expecting through. So machine learning system actually it improves over the time iteration. So like even we go as the data is being fed, more and more it has been fed to the system, the more accurately the machine learning model can go, and it can help you in vehicle monitoring. The machine learning model might initially learn to detect defects like common issues, but as we go on feeding more and more data, it can also help in small defects which are very minor, very small. Or like for example, if there is small crack which had just initiated in it, like for example in a gear component, so machine learning model can help us to do that or predict that particular thing. In the machine learning, we use different categories of learning. So one is like supervised learning, unsupervised learning, and the reinforced learning. So supervised learning is like the simple thing about supervised learning I would like to tell is about the labeled data. Like for example, we capture the temperature, and we tell that we'll tell that particular that this is the temperature data captured at the gear at the brake. Or if you capture the temperature at the engine part, so we can say that this is the gear temperature data captured at the engine part. Okay, so we give the labeling of the data. Usually like just we tell the machine that this is that data, so that actually has helped the machine to train more efficiently. Another is like unsupervised learning. Unsupervised learning is like when more complicated data comes in, or the data which has a lot of information, or like for example temperature data. So temperature data is coming from brakes, it's coming from gear, it's coming from different element like engine. Okay, and if a lot of common data is coming in, it become very difficult to label those. Okay, and in that case, like unsupervised learning is being used. In unsupervised learning, it makes use of the cluster. So it's from the cluster of data. So this is like a data of temperature from brake, temperature from cluster of temperature from gear, or temperature from the engine. And based on the cluster, the model has been turned. Another is like the reinforced learning. The reinforced learning is again like supervised learning has its own limitations and advantages, while unsupervised also it has own limitation advantages. But if we use the advantages of supervised learning and some advantages of unsupervised learning, and we combine them together, so this comes under the category of like reinforced learning, or it is also called as a hybrid learning. So this is the broad category of the thing. So now what's the pipeline for processing the data in machine learning, especially like when we go for the condition monitoring. So actually like the figure here shows the pipeline of the flow of data, like right from acquisition to the model building. So it also highlights the essential steps to be taken for transferring the raw data into the actionable insights. So first step is data acquisition. Now there is a sensor in place. Now the sensor go on like capturing the data from the machine. Now the data could be like in terms of vibration, temperature, torque, or any other signals that are critical for monitoring the health of the vehicle component. Now the data can be like in offline log or through then online streams. Offline log is like we fix some sort of like DAX system to the sensor, and it helps you to capture data through the DAX system, and that can be connected to your computer there. Or online is like as I said before, it's like when your vehicle is or some and a company is at a distance, a far distance from your geographical location. Then in that case you can stream that online data. So that is a different way of where the data is captured. So then the next step is like design processing pipeline. So the collected data is then processed to make sure that it is suitable for machine learning model. Okay, so like the model different like frequency domain analysis or time series analysis. Okay, so the model here means like based on the data, like what model is suitable for that particular data. Like if you're capturing the vibration across time, then the time series model is very important. If you're capturing the data in frequency domain, so frequency domain analysis is like very important thing. And then the third step here involves the data is structured, clean, and ready for machine learning. So it's not obviously like when you capture the data, there is a good data and bad. So there is obviously there is some sort of noise in the data. So we need to remove that. So next slides we'll look at how actually those noises are being removed, or how actually the noise is being featured out of from any data there. And the fourth step is like using machine learning algorithm. So that is like training the model that can help you to analyze the pattern. So like it is like forecasting the future thing to build the predictiveness of the monitoring condition there. And the last is like fifth step is like model evaluation. So once we have all the thing in place, the model is evaluated. So it's like training, testing. Okay, and then comes like a validation. So when the model is being tested, we evaluate like a confusion matrix. So this confusion matrix is helps you to understand like how the data is being analyzed. Okay, whether it's being that the model has predicted accurately. If it's correctly, if it has predicted correctly, how much is that percentage? If it is not, how much is that percentage? Right. So this is where the model evaluation of the machine learning model will take place. So there are different techniques I've just summarized here. So there are many different soft sensors that are being used to capture the data. There are different in this particular slide is like there are different functions of each and every sensor. What is the role of each sensor and application? Okay, so where is this particular sensor applied? So this is like a brief overview of different type of sensors that are being used in vehicle or monitor the condition of the vehicle components and help us you to give the decision. The next important take is the data synchronization. Okay, so now the most important thing is like we have putting this many sensors in a vehicle component. Okay, so there is multiple data coming in. So it's not like every sensor will capture at same time step. Okay, some sensor will capture at some point. Some every time step will be different for every sensor. But we need to integrate all them together. The data integration is very important. So we need to bring this data at one location. Although like they are different time, we need to bring them together and analyze this data in real time together. Okay, like for example, you're recording the time temperature at different time step, you're recording vibration at different time step. Okay, but at the end they should come together and they should be generalized at one time step. So there should be like interpolation between the data. So that is very important because it helps you, it will help you to give a good informed decision in real time. So like that is like data synchronization, where the time stepping, like it assigns precision time maker to each data point, ensuring that data from different sensors can be matched at the same moment. So these particular gaps are being filled by interpolation. Usually, like interpolation means we use some sort of like uh, methods, regression methods, or data fitting techniques, which helps you to or will like analyze the trend, which helps you to fill in this gap or temporary time or moment gap between the each and every data has been captured. Now again, we obviously interpolation means like we are generalizing the thing. It's not like it shouldn't be generalize a thing that is like not suitable for the vehicle component. So calibration is another very important thing. So which is like once we interpolate the data, we again that calibrated data with the sensor, looking at this, whatever we have interpolated has been is in a good accuracy with the measured data. Another important thing is data is like feature extraction. So feature extraction is where, so this is where the part where the role of human come in. So in the previous slides, I explained about damage. So we need to have information about damages, and based on that, we need to extract the features. So every element captured by the sensor, it's not necessary that every element is required or true. Some of the time can be like it can capture the false positive. Okay, so that's very important to understand. So as once we have a basic fundamentals of damage and defects in the components, it can help you to reframe the data and extract the features. So while doing that, we usually follow three different methods for conditional and conditional models. One is like the statistical feature extraction, where the raw data is analyzed in time domain. So by using the statistical measures like means, variance, kurtosis, or skewness, so this is like helps you to understand the operational behavior of the machine. The next another method is like frequency signature identification. So frequency domain analyzers focus on the decomposed signal over the time, and this make use a method like a fast a Fourier transform or like any other like specific fault signatures that helps you to understand the condition of the vehicle component. And last is dynamic feature representation. So this is dynamic feature representation means the time and frequency domain analysis that captures both the temporal and the frequency vibration in the non-stationary signals. So techniques like wavelet transforms are being used to analyze the transient phenomena. So this particular feature extraction is like for example, if there is a sudden spike in the vibration, so that is where feature is. Okay, now data is behaving normally, it's okay, but like some point like there is damage in the track, so that causes sudden spike in the vibration or in the value there, vibration value there. So that is what the feature is. So as an engineer or analysis, so we need to understand like this feature is very important, because this value or this threshold will definitely give us understanding of what type of defect and the vehicle component has experienced. Another feature selection, like as I said before, feature selection is one of the very important thing. So once you extract the features out of the data, then how to select the features from it. Okay, so in the data processing or machine learning where the condition monitoring is required, feature selection ensures that the most relevant and impactful data is being used, and it also enhances model accuracy, because the more the data you give to the model, obviously this is like a training. It will take a lot of time, computational time, to train the data. So it's very important that you give useful data to the machine learning model, so that will help you to pinpoint actual defects or damage in the vehicle component. So these are the different techniques that are being used to for selecting the good features in a thing. Now, how to integrate the data processing with the machine learning models? Okay, so now till now we were looking at data, capturing the data processing pipeline, like how the data is being processed, or how is the features being eliminated, or what are the important features that have been taken out from the component there. But how are they being integrated with the machine learning model? So this is what we are going to look at. So now there are different machine learning models which can help you to integrate the data with the thing. So one is like the CNN, convolution neural network model. So usually this is like this particular model makes use of image data. So if you have an image of, like, let's say from the camera sensors or thermal cameras temperature, so you get that image. Process each and every small pixels within the image, so that helps you to give whether to classify the defects, like whether it's the defect or it's some sort of like an open damage, or it's like okay to go. Okay, so in the CNN models, there are different layers, like input layer where the input image is being given. Convolution layer is like now the particular image will be focused with small pixels within that image, and some edges or patterns will be identified with the filter kernels. And then pulling of layer. So once like we have this pixel data, and so next stage is like reduce the data size by preserving the key features and improving the efficiency. And then at last is connecting all these pulling layers together to get one informed decision, like whether, or to classify the elements in the model, like for example whether it's a defect, or whether it's like a damage, or it's like a good okay to go component. Another is like when in an unsupervised learning. So as I've said before, in unsupervised learning, it make use of a cluster. So in the slide here, particular focus on how the supervised learning techniques are applied on the data processing, which are being used for condition monitoring. So like if you look at the figure on the right side, so there's a graph which shows small cluster. It's in the red dot, purple, and a green dot. Okay, so now here the supervised learning, once we give the data to the algorithm, it will divide the model. The model will divide into a small cluster, or classify the data, whether this is like the temperature from the braking system, or temperature from the engine, or temperature from the gears. So accordingly, the data will help, this particular unsupervised learning will help us to carry. So like here we can use like k-mean clustering. Okay, so a different thing can be used for preparing the cluster of data. There's like a Gaussian mixture model, or like self-organizing maps. So there are different machine learning and supervised learning models which are being used to prepare the cluster of the data. Next is the hybrid or reinforced machine learning. So where they actually make use of both the advantages of supervised and unsupervised learning approaches. And this likely concept like combines the strength of both method to enhance the machine learning applications for processing the data, especially in the condition monitoring system. So like supervised learning, it relies more on the labeled data to make the precise decision, while the supervised learning, on the other hand, like works without labels. Okay, so in the real power lies in combining this two approach, which will give you a hybrid learning model. So by integrating the supervised and unsupervised learning, we can achieve the greater adaptability and accuracy. For example, the unsupervised component can uncover hidden patterns or group unlabeled data, which can then perform and refine the supervised model. Like the supervised learning, like we need to label data, but as a human, we do have some limitations. Some data can be missed, but based on the information provided, the model, the unsupervised learning can help us to identify that cluster or type of data and process, and help to refine the supervised learning model, and then getting the final benefits of both the supervised and unsupervised learning together. Another is the deep learning approach. So again, this is like an image processing approach where we capture the deep learning model. So usually deep learning is considered to be like a lightweight models. Now, we are talking about data. The more the data, high computationally, it requires that much high efficiency. Okay, but what happens, like when we have feed more amount of data to the model, sometimes the model may take time, or it becomes like absolute. The model becomes completely absolute, or it may go with like overfitting. This is like very challenging part. Overfitting and underfitting is one of the challenging part, which causes the issue with the thing. But what is deep learning? Deep learning is like they have a set of data, like there is a set of data of different features. We call that as particular pre-trained models, pre-training, training the model on already available data, like data of like vehicle component, or data of like there is a the flowers, the house, or different like house, different features. Okay, different features. So there is a data. These body models are like pre-trained on the generic data that are available on the easily available on the website, or any of the thing. You train that model, and once the model has been trained, you inject your data in that particular model. Means like you train that on, and then you test on your model. So once you do that, like it's like it will take a benefit of feature extractions from the generic data and your data, and it will give you some good informed decision in a quicker way. So that is where the deep learning model works in. And another is like the time series analysis. So this is another way of data processing and machine learning. Time series analysis is like this is like more aligned with the vibration data, or when we have a data of like for example, in the previous slides we talk about the test bench, where the engine torque data of like a high engine torque. So in that case, the time series model can be built with that. So time series model is like it look at the trend, how the trend is behaving, then that trend line being used to detect the defects. And if there is any defect in between, the future step is the third step is like we use that time series model to forecast any future defects. Okay, so this is like more towards the predictive maintenance. Okay, so like for example, like for example, just like for example, you are replacing the brake pads every, like let's say every year or every 2 year. So the data tells that every 2 years, like you are replacing the brake pad. So this is what usual practice we do. That is like normal predictive, normal maintaining. But predictive maintenance, that will help you to understand like when to replace that particular brake pads or any other elements in the vehicle components. Okay, so this is when time series data is very important. Analysis is very important when we go for the predictive maintenance thing. There are other techniques as well for data processing, which where the edge computing in real time, or cloud computing for large data management, or another is like cooperative perception and swan intelligence in autonomous system. Now, this is like more in like EVs. So this is the technology implemented in EVs there. So now at the end, like we need to integrate this all together: sensor, data featuring, and the machine learning model, because this everything has to be deployed on the vehicle component. So overall integration of sensor, data, and machine learning is very critical for building intelligent system, so that enhance the safety, reliability, and efficiency of the vehicle conditions there. So important of real time is like it captures the data at real time. The importance of machine learning is it helps you to give the informed decision, and the role of data fusion is like it helps you to understand like what is the defect, whether the defects, how are the defects, and when to carry out the conditioning work or maintenance work of the vehicle component there. So this is all about the thing. So in summary, I would like to talk about what we looked in. So initially we looked on all the different damages in the vehicle component. Then we looked on what are the different sensors that are being used for condition monitoring. And then we looked on how our machine learning models are being used to how machine learning model are make to make use of intelligent decisions. And then we also talked about like online data conditioning, so where is like Internet of Vehicles, where like 5G communication is nowadays in big boom. So like how this can be implemented in online condition monitoring, online real-time condition monitoring. Then in this previous slide, we talk about predictive maintenance. It's very crucial, very important part where time series models are being used widely. And we also talked about like how computational data or big data is being used to uh, do the forecasting, detecting anomalies or forecasting and making some real-time decisions. So this is all about my presentation. I would like to talk here about the process monitoring and the defect detections in the vehicle components. Thank you very much, and I'm happy to answer any questions you have.
So there's a question in the chat box from Mr. Jevelu. So what is the AL and ML? Which AL or ML technique will be suitable for application?
Yeah. See, it depends on like what conditions you're monitoring. Like for example, you are using image data. So in image data, like deep learning techniques are being widely like deep learning models. There are different models like AlexNet, VGNet, different. Those are called the pre-trained models. So in that is one way of doing that. So it depends on type of data you're using. Some are like, for example, you have a data of the vibrations or spikes. So in that case, like you can go for like supervised learning, where like the care nearest neighbors or nearest base or anything that can be used for that purpose, or like they support vector machines. Okay, so it depends on type of data that you are going to record and what type what is the sensor used, and based on that you decide like which techniques will be suitable for you. So like usually we calculate image and the text data. So for image, it's good to go with the image processing. Even like LLM models are being used, large learning models. So there's also like one of good techniques for image-based data. So it depends on like the data that you're going to process.
So another question from Mr. Venkatesh is asking for any preventive measures, whether any preventive measures are available for defect detection.
Preventive measures, usually like nowadays we just go with like predictive maintenance. We just detect any kind of a defects or damages quite early, and then we go for like, for example, if you want to take any preventive measures in the gear element, like for example, if your data says that there is a damage in a gear. Now, how can you do that? So like we can make use of some additive manufacturing techniques to repair that, or we can make use of some what do you say, any kind of a supporting techniques. So like for example, what happens sometimes, like you nowadays, like for example, if your machine says that is this is the time at which your maintenance is due. So like for example, there's a defect in the damn component, then we give instructions to the operator or the manufacturer to manufacture some part, and they can make us part readily available or easily available beforehand. So there are different ways of repairing or making preventive measures to avoid this type of downtimes in the vehicle. But additive is like quite widely used for preventive measures.
Good afternoon to one and all present here. First, I would like to thank the organizer and the ACTA ATAL Academy for providing this platform to exchange knowledge on artificial intelligence in hydrogen and electric powered vehicles. I would like to thank today's resource person, Dr. Sagar, for presenting the topic, process monitoring and defect detection using AI in vehicle components. So it has provided insights into how artificial intelligence can enhance the quality in vehicle components, especially in the in context of hydrogen and electric powered vehicles. I would like to thank the organizer Dr. P.D. Jayakumar sir and Dr. R.K. Julius sir for their planning and execution and ensuring the smooth conduct of this session. I would like to thank everyone.
Right. Thank you very much. Thank you very much for giving this opportunity. And thank you very much to the institute and the team who organized this FDP, excellent FDP. And thank you very much for giving me this opportunity to deliver the talk here.